Hello and welcome everyone. This is my report progress presentation for WRD204. My report is about two methods of valve actuation, and I'm Logan Varney. So the audience and the purpose of my report is to inform current and future mechanical engineers that are interested in automotive design and automotive manufacturing that attend the University of Kentucky. And the main purpose is to discuss one facet of engine design, and that would be in the camshaft. This diagram on the left here shows a simplified version of an engine. It has all the moving parts, and it only shows one cylinder. Most cars today either have 4, 6, or 8 cylinders, depending on what car you get. And so the focus of my report is the camshaft and a recently found technology known as free valve. The camshaft, which is in the lower right hand of the diagram, uses shaped lobes that ride on a shaft to push the valve downward into the engine, and the spring pushes it back up. So the camshaft has to come in contact with the tappet, which pushes the push rod and the rocker arm so that the valve gets pushed down so that air can come in or out of the engine. There are several different types of engines that use camshafts, and that would be the push rod engine, the single overhead cam, and the double overhead cam. In all of these cases, the crankshaft and the camshaft are linked together either using a timing belt or timing chain. And so in the push rod engine here on the left, you see that the cam pushes up on a push rod that hits a rocker arm that actuates your valve. In the single overhead cam in the center there, the cam hits on a little arm that gets pushed down, which pushes the valve down. And the valve deals with both the intake and the exhaust valves. With the double overhead cam on the right, you see that each cam only deals with either the intake or the exhaust. That allows for an easier swap if you want to go with, say you want to change your intake, but you want to leave your exhaust the same. That's much easier to do, whereas with single overhead or the push rod, you have to change your entire cam in order to get a different either intake or exhaust profile. Now, with free valve, they use solenoids, which is a circuit, and then you either switch the circuit on or off, and that pushes the plunger up or down, which either opens or closes, whatever it is attached to. In this case, it's a liquid. You're sending pressure through a membrane, and you open and close the membrane with the solenoid. In the case of free valve inside of an engine, you use that solenoid either to push down or pull up on a valve in order to open or close it and let air and fuel into your engine. Now, different camshafts can have different duration and different lift, and that is determined wholly by the shape of the lobes on the camshaft. You can either have a more pointed profile as seen here in the picture on the right, or you can have what's known as a roller camshaft, which has more of a rounded profile, which allows for more duration and more lift, which means that you get more air and fuel into your engine, which can increase the power. And with free valve technology, you can have any sort of duration or any sort of lift that you want. You just have to change your software and program it differently so that the solenoids open and close at the right times so that you have whatever duration and whatever lift that you want. Now, lift is the difference between the base circle, which is the gray portion on the diagram, and the difference between that and either the blue or the red, which is your intake and exhaust. And duration is how many degrees of one rotation is that valve open for. Say you have, 180 degrees of duration, that means it is open for half of a revolution. And from my analysis, I have found that camshafts are a much more permanent change to an engine than a free valve. In order to cam swap with a free valve, you only need to change your software. You reprogram some things, you change a few values in a computer program, and it's changed. Whereas a camshaft swap can take hours or days, and the engine will still need some tuning and some changes in order to run just the way you want it. Now you do these changes to change the performance, change the fuel economy, what have you. It's a very customizable and easy to change part of your engine, whereas say the crankshaft or any other part of the assembly that rotates is a much harder thing to change. Now, as for my completed work, I've completed most of the front matter, including the abstract, the letter of transmittal, the title page. I've also completed my introduction, and I have listed my methods in my report thus far. As for my remaining work, I need to read up on some more literature and analyze it and detail my findings. I also had to conclude my report and discuss any future research that can be done for this, and add a works cited, and I'll have to add more citations in and create an appendix of vocabulary so that the reader can reference that at any time instead of having to dig through my report. If you have any feedback, please share it with me, let me know. Please put a relevant subject line in your email so that I don't miss it or I don't mistake it for something else. And both of my emails are there. I also put my email in the submission in discussion number 7. And my sources are here, and my sources are just for all of the videos and pictures in my report. Thank you.